Today we're going to talk about loops and the App Inventor activity called Keep Me in the Loop. A loop is a command that repeats a set of instructions until a condition is met. And they are a fundamental programming concept along with conditionals and procedures. The benefits of having a loop are that it saves time because there are fewer blocks to set or place, and when it comes time to updating your code, there's fewer blocks to look through to find where you need to update. It reduces redundancy. Redundancy is where you duplicate or replicate code in different areas of the application. And it makes it easier for you to manage your code. Your code is more organized and easier for you to understand and for others to understand that may have to look at your code. So let's take an example here. Suppose you had to bake cupcakes for everyone in school. The recipe for that, many students, requires 200 eggs. What are the options? Well, option 1 in the recipe would be to list crack an egg into the mixing bowl 200 times. With this method here, it would be very easy to lose count. Make sure that you had the exact number of eggs in the recipe that you needed. Second option would be to say crack 200 eggs into a mixing bowl. But if you tell that to a computer, the computer's not going to understand that you mean that you want to crack one egg at a time 200 times. It's going to take 200 eggs and crack them all simultaneously, which would be a big mess. The third option would be to say something like crack an egg into the mixing bowl and then repeat the previous instruction for all eggs that are required. And that is the best option. That's also the loop option that we have here. So when we talk about loops, there's two types of loops. There is a definite loop. A definite loop is a sequence of instructions that repeats a specific number of times. We know before we hit the loop exactly how many times that it's going to repeat. We know the starting point, we know the ending point, and we know how much the loop is going to change each time. The other type is an indefinite loop. An indefinite loop is a sequence of instructions that repeats until a certain condition is met. We don't know how many times that loop is going to repeat. We just know that it's going to stop repeating once we meet that condition. So in App Inventor, we have one block set for a definite loop, and that's the for each number block that's shown there. It's also called a for next loop in other programming languages. On the indefinite loop side in App Inventor, we have two choices. We have the for each item in list, which looks an awful lot like the for each number loop that's on the definite side. And then we have the while test do block. And we're going to talk about each of these blocks individually. The for each number block looks like this, and you can see that there are some blue blocks over on the right hand side there with the words from, to, and by next to it. These are all called parameters. We set the parameters to tell the block how many times we want to loop. In this parameters, the first parameter is from, and that gives us our beginning value. The next parameter is to, and that tells us the ending value. And the third parameter is by, and that tells us our change value. So in this example block here, it says for each number from 1 to 5, by 1 means that we're going to start counting at 1, we're going to end counting at 5, and we're going to increase each time through by 1. So it would be 1, 2, 3, 4, 5. And you can see the number up there after the word each. That is a variable that you can use. So if we wanted to know what number we're currently on, we could use a variable block and pick out number there, and then it would be able to tell us which time through the loop that we're through. And finally, the last place in this block here is a place for our code that we want to repeat. Anything that we put down in next to this word do here will repeat however many number of times that we have in the settings and the parameters up at the top. So for the each number block, I'll give you some examples. First example here is the one that I already gave. We want to crack some eggs into a bowl, and we want to repeat for all of our eggs. So we know that there's 200 eggs. We're going to start counting at 1 and go up to 200. So our from is 1, our to is 200, and we're counting by 1, so the by would be 1. And then the instruction would be crack the egg into the bowl, which I have represented with the procedure here. Another example would be count down from 10 to 0, then launch the rocket. So in this case, we want to start at 10 and work our way down to 0. So our counting has to be in the negative direction. And we're going by 1, so our by is going to be -1. And then the code that we have in the do section and the repeat section here, I just have it updating a label with the current number. And you can see here that I use the get number variable block to get that actual value. And it repeats all the way through there. Once we get to 0, then it's going to call that procedure that does whatever it needs to do to launch the rocket. That last block there, the call rocket, only runs after the loop is done because it's outside of that loop block. And the third example that we have, list all numbers from 0 to 100 that are divisible by 7. Okay, so on this one, we want all the numbers from 0 to 100. So our from is going to be 0, our to is going to be 100, but the by is going to be 7 because we want them to be divisible by 7. And so when we go through and count, the first time through the loop, the number is going to be 0. The second time through the loop, it's going to be 0 plus 7, which is 7. The next time through the loop, it's going to be 7 plus 7 is 14, etc., and so on. So it's only going to give the values that are multiples of 7, which is another way of saying divisible by 7. And then the repeated code is just putting those numbers into a label. So those are examples for the for each number block. The next type of block we have is for the for each item in list block, which I said earlier looks a little bit like the for each number block. This one is an indefinite loop because we don't know how many items are in the list, so we don't know how many times the loop is going to run. It could be 1, it could be 100. We won't know until we run through the list. The change value in the for each item in the list is automatically set to 1. It's going to go through each item in the list, so it's going to start at the first item and work its way through, increasing by 1 each time through. So here's the block here for each item in list, and then we have the do and then the code to repeat. The code to repeat is going to be the same type of stuff that we had for the previous example. Whatever code we want to run a number of times is going to go inside there. The difference with this one here is that we have a socket on the right-hand side of the block. This socket is for the name of the list, and we put the name of the list in an orange variable block, like the one shown here, where we get global list name. And we want to make sure we use the get block because it has the tab on the left to fit into the socket on the right of the for each item block. In order to have that get block, we have to first declare our list or declare our variable for what we need. Okay, so let's look at some examples for each item in list. Let's say that I had to grade a quiz for each student and then record that in PowerSchool, and I wanted to have an app to do that automatically. So I could do something like this. For each item in list, and then my list is the class list. Then I could have a procedure that would grade the quiz, and then a second procedure right after that would take the grade and send it to PowerSchool so that it could be recorded. And then that would loop all the way through for every member that's in the class list. Second example, let's say I had a to-do list and I wanted to mark everything as completed. I could do that by saying for each item in list, where my list is the to-do list, and then I could set the global status complete to true. Now what's not apparent here is that status complete also has to be a list that parallels the to-do list. So I have the to-do list that has the actual activities that I have to perform, and then I have a second list called status complete that is only going to hold either true or false, depending on whether the list is done or not, or that activity is done or not. So when we have two lists working together, they're called parallel lists. The third example I have, let's say that we're having a virtual day, like today, and I wanted to set up an app that would call all the teachers and leave a message for them that it is a virtual day. Well, I could do something like this in an app. For each item in the list, where the list is the teacher's cell phone numbers, I could do a procedure that would dial the phone, and then another that would speak into the phone whatever message that I have in the variable called virtual day message. Then I could change that message out for different types of virtual days, whether it be for weather or for a gas leak, or whatever it happened to be. Okay, the last block then is a while test do block. The while test do block is also an indefinite loop. We don't know how many times it repeats, but we don't have a list, so we don't know what to walk through. So we're going to change the value within that loop in those repeated code blocks. When some value reaches our criteria point, then we'll exit the loop. So on this, we have a socket on the right, just like we did for the for each item in list. But the socket on the right for this has to list what that test is, that criteria to exit the loop. If that test evaluates to true, then we're going to stay in the loop. As soon as that test evaluates to false, then we're going to skip out and then go on to the code that's after the loop. So that test has to evaluate to either true or false, making it a Boolean test. Most of the time you'll see where we're going to use the math equals block in there, and there's a picture of it on the screen. That equals block can also handle inequalities, less than, greater than, less than or equal to, greater than or equal to, and also not equal to. So we can handle all sorts of tests using that block right there. And then the two spaces inside of that blue block is for the two values that we are testing to see if they're equal or not equal, etc. And then once again, we still have a place for the code to repeat. So let's look at some examples of this one. Let's say that I wanted to allow purchases on a credit card while we're still under our credit limit. So the code blocks would look something like this. While, and then the test is our purchases less than our credit limit? If it is, that's true, and then we'll be able to do the procedure there to make a purchase. If it's not, if purchases are greater than our credit limit, meaning that we've spent more than our credit limit, it's going to skip the code that's in the loop and just exit it and move on. Or maybe on a cold day like today, we want to run the furnace when the temperature is less than 70. Once it gets to be 70 degrees in the room, then we want to shut the furnace off to save some money. So then we would have a test that looks like this. Once again, we have our while test block, but the test is we get the current temperature. If it's less than or equal to 70, then we're going to run the furnace. Once it reaches 70, it's no longer less than or equal to, well, actually 71 in this case, then it'll shut the furnace off because it'll skip that call to run the furnace. Okay, so let's talk about your activity for today. Your activity is in Project Lead the Way. It's in Lesson 2, and it's called Keep Me in the Loop. Now, you want to be very careful here because if you look in the contents on the left-hand side here, you can see that there are two Lesson 2s, one called Game Design and one called Taking It to the Next Level. We don't want the Game Design one. We want the Taking It to the Next Level. And so you're going to have to click on that one to get you to the Keep Me in the Loop activity. If you click on Lesson 2 and it says the Activity 2.1 is Game Time, that's the wrong one, and you're going to have to go back and click on the other Lesson 2. Okay, so first thing that we're going to do then is we are going to scroll down just a little bit to the resources table there, and you can see that there is a data file called AC_2_1 keep me in the loop.aia. Just like on all the other data files, you have to click on that, download it to your Chromebook, and then import that into App Inventor 2. Once you have it in App Inventor 2, it'll look like this on the design screen, and it looks fairly familiar. We've got the bus that needs to get from the school to the museum, just like we did in our flowcharts. There are no street signs on this one, so you can pick any route that you want. And we're actually going to move the bus. The bus is a sprite on there, and we're going to move the bus to get it go across the roads to the actual museum. Okay, the first thing that we do whenever we download a data file is we need to go to Projects, Save Project As, Get rid of the word copy at the end there and replace it with your name or your initials. Click on OK so that the name of the file on the left-hand side of the green bar up there at the top shows that it's your file. We're not going to make any changes to the designer screen here besides changing the name of the file. So then after that, we're going to go to the block screen. And you can see on the block screen that there's already quite a bit of stuff in there. We're not going to mess with any of the stuff that's in there. All we need to do is to program the start button so that when we hit start, it will run the path of the bus, whatever path you decide to give it. The reset button is already done. Everything else is already set. So you're going to have to go over into the blocks palette on the left there, find in the screen 1 section there, click on start button to bring up the start button. Event handlers, we want the top one, the start button click, and we're going to click on that and drag it out into our work area there. Once we have that, then we need to get our loop block, and so we're going to click on the control section in the built-in, and then if we look after the conditionals, the 3 conditional, the 4th block down from the top is the for each number block. We're going to get that one, and we're going to put that inside of our start button click event. Okay, so looking at the map here with our bus starting at the school, the very first thing we need to do is move forward 4 times to get us to that first corner. So there's already a block in there for moving forward. So we are going to change this for each number block so that it moves forward 4 times. You notice that our from is 1, our to is 5 by default, and our by is 1. Well, the only one we need to change is the to, because we don't want to go 5 blocks, we want to go 4 blocks. So we will change that 5 to 4, and so now we're going to be moving 4 blocks. And then the code that we want to repeat is to move forward. Well, in the purple procedures block in the palette there, there's a block called call move forward. And we're going to click that and put that inside of our repeated code there. And that then will get our bus to go from the school up to the first corner. The next thing we need to do is we need to get the bus to turn left. So once again, in that procedures purple section in the built-in, if we click on that, there is a procedure called call turn left. Okay, so in order to turn left here, we are going to get the call turn left, and we need to make sure we're putting that after the loop. You notice it's not inside that do, it's after the loop, because we want to turn left 1 time, not 4 times. We want to move forward 4 times and then turn left once. So it's got to be outside of that loop, but still inside the start button click event handler. And then that will have the effect of rotating our bus 90 degrees counterclockwise, so it's now pointing to the left. And then the next thing, we need to move forward and to get to the next intersection, and that is going to be moving forward 2 to get us to that intersection. So we're going to have another loop block here, just like the first one, only this time now our to number is the number 2, because we want to move forward 2 spaces. And so we're going to duplicate that first loop block and have everything the same with the move forward in the repeated code. The only change we need to make is changing the to number to the number ones that we want to move. And that will then move us forward 2. Now we have a decision to make. Do I want to turn right and take one of the upper paths, or do I want to turn left and take that lower path? And that's your decision. What you need to do now is you need to finish this up. You need to continue adding blocks to the start button click event here to get the bus all the way to the museum by whichever path that you want to take, as long as that path stays on the roads. You also have to make sure that whenever we move forward more than once in a row, that we use a loop. Don't put 2 move forwards together or 3 move forwards together or anything like that. Whenever we move forward more than once, it's got to be inside of a loop. Okay, once you have that done, it's kind of hard to do this part in the virtual, so I will give you time once we get back in class to test the app by loading it on the tablet. If you happen to have your own Android phone or you happen to have your own Android device, and you could download the AI companion from the Google Play Store and try it out on your own. But like I said, if you don't have an Android device, then you can go ahead and just wait until you get back to class for that. And then if you've tested the app and it works, or even if it doesn't, but you think that it probably will, then you can get ready to turn it in. Same as all the others. You're going to get screenshots. You're going to get a screenshot of the designer screen. You're going to get a screenshot of the block screen. You might have to zoom out in order to get all of the code that's in the start event handler, because there's going to be quite a bit of code blocks in there. Or you could take multiple screenshots to go all the way through. There's one conclusion question up at the top that you need to do. And if you watch this video, you should be able to fill in those parts of the for each number block, all those parameters. You should be able to fill that in without any problems. If not, rewind the video and take another look. And then once you've got the screenshots, you've answered the conclusion question, you need to export the file from App Inventor, attach it to the Google Classroom assignment, and then turn that assignment in. If you're confident that you have it right before we get back to school, then you can skip the testing part and just turn it in anyway. Okay, so that's it for the lesson today. Let's get to it.